Hello and welcome to today's webinar from InfoQ. It's from our friends at ScyllaDB. Here's the title, Learning Rust the Hard Way for a Production Kafka and ScyllaDB Pipeline. My name is Stuart Ruckel. I'll be moderating the webinar here today. And I'm delighted to be here with two wonderful people that have done a lot for the InfoQ community as well as the ScyllaDB community. Peter Corliss from ScyllaDB and Alexei Jacob from Numberly. We have a fantastic presentation prepared for you here today that will really take you through what it's like to make the transition to Rust and talk about why the transition was really made, particularly for things like performance. Before we really jump into it, though, we would love to get a sense of where you all are at as an audience and start with a couple of poll questions. So if you look in the GoToWebinar console, you'll see some poll questions. We have a couple here for you. The first one is, where are you in your NoSQL adoption? I think it's really no secret that everybody's moving to a number of different databases depending on what their service requires. NoSQL is a big part of what a lot of organizations are looking at, so please tell us where you're at with this. Are you currently using ScyllaDB? Are you currently using another NoSQL database? Are you evaluating NoSQL? Are you interested in learning more? Or are you really kind of at the very beginning of this journey and not really thinking about NoSQL really at all? Looks like we've got some poll results coming in here, and a decent number of you are already using NoSQL, which is great. And then if you smash that together with folks currently evaluating NoSQL, there's a majority of folks on the call that are already on this journey, which is fantastic. And hopefully the conversation here today will help further your understanding for some of this, for those of you that have already started. And for those of you that may be just getting your feet wet, that's a good place to be as well. Another poll question, the second one, is how much data under management of your transactional databases do you have? This is the amount of volume of data inside an enterprise is really exploding. Are you looking at less than a terabyte, between 1 to 10 terabytes, 10 to 100 terabytes, or more than 100 terabytes? Give us a sense of the data you're working with the projects you're looking after, these days. This again will help us kind of fine tune the content and understand where folks may be in terms of scale and in terms of some of the volume and performance requirements you may be looking to work with. All right, here we are. We've got half the folks are not looking at much data at this point, while some others are. Actually, some pretty remarkable scale. So we've got a nice bifurcation here with modest volumes, and then a vast majority of you, or a majority of you, are looking at some pretty substantial volumes as well. So that's interesting. Thanks, folks, for your participation. Let's jump now to the main program that we have. I'd like to turn it over to my friend Peter Corliss from ScyllaDB. Done a lot of great stuff in the community. Peter, over to you to walk us through the content here today, and then to introduce our flagship speaker. Welcome, Peter.
Thanks very much, Jared. My role at ScyllaDB has been to be this director of technical advocacy. To be an advocate means to speak on behalf of. And I think that these poll questions just told us a story about who you are and where you are. A lot of people probably already have some mix of SQL and NoSQL in their shops. I noticed that a fifth of you said that you're not interested in NoSQL or pretty much database. So that might either be that you're using SQL databases or you're just here for the Rust content. And so we want to get to that as quickly as possible. I write blogs, case studies, and I'm a gamer at heart, and so I always try and find what is the underlying game theory behind why people use technologies, or what is the win-win that we can all get out of using these kind of techniques. So for any of these reasons, you can follow me at Peter Corliss on Twitter. But now let's tell you not just about me, but about the technology I'm representing today, ScyllaDB, and it is the database built for game changers. It was designed not by, the context was that our founders came from the KVM hypervisor world. And so what they were seeing was that these modern multiprocessor systems were practically a network in and of themselves. And so they came with that knowledge of how to carve up a system into multiple different units of work. And that's really where the origin of ScyllaDB came from. So it's very unlike, in many cases, very unlike a lot of traditional databases because of that. And because of this revolutionary new architecture, it gets much higher throughput, sometimes up to 5 times the throughput that you get on other similar types of databases. You can get up to 20 times lower latency. And again, when we talk about these new Rust-based applications, that's an incredible thing, to be able to have a data store that can keep up with your really fast performing applications. And then best of all, especially these days, is you can save up to about 3/4 of your spend. And so this allows you to run applications and get the ROI that you were looking for when you had these thoughts about giant terabyte plus scale systems. And again, we saw people out there in the poll running at way more than 100 terabytes of data. So it's very exciting stuff. Now, we're just about to talk to you about some of the use cases here. There are tons of companies that I call game changers. These are companies that are just over-ending their own industries or creating whole new industries using ScyllaDB. And you can just see some of the logos here. You have streaming services like Disney Plus Hotstar and Hulu and Tubi TV. You have shopping services that are huge, including Rakuten or Fanatics or Instacart. And today what we're going to be talking about is a particular use case that is an ad tech use case. And I'm about to introduce my friend here, Alexis Jacobs, who has been changing the ad tech industry at Numberly, a French ad tech company. And so with that, Alexis, you're the person who's got the real story today. So why don't you take it away?
Hello, everyone, and thanks for joining. So my name is Alexis. Thanks for Peter for the introduction. I'm CTO at Numberly. I've been using ScyllaDB for quite a few years now. I'm an open source author and contributor. I've been contributing to various Apache or NoSQL related and even documentation related projects. I'm a tech speaker and writer, obviously, and I've been also a Gentoo Linux developer for more than 10 years. And I'm also a Python Software Foundation contributing member, which means that I spend a fair amount of my time contributing to Python-based projects. Here is the quick agenda of today's presentation. I will share with you the thought process to move from Python to Rust in our use case, so some context and arguments and decisions. I will share with you the learning in learning Rust the hard way and why I've called this learning Rust the hard way. So the stack components I had to deal with, and some tips and tricks and open source contributions that came along the way. And then I will take a step back and look at if it was a worth experience with sharing graphs and production numbers. So here we go. Choosing Rust over Python. I've been doing Python in production for more than 15 years now. That's as much as a marker that my age is advancing, as well as a shock to my colleagues that I could even consider to code using another language than Python. So what could trigger such a radical change on me? As a data company, we operate on a lot of data that is fast moving using an event-driven approach that drives our technological choices towards platforms that allow us to process and react to stimulus as close to real time as possible. For this, we combine Kafka and Scylla extensively on streams and specialized pipeline applications that we will call data processors here. Each of those pipeline data processor applications prepare and enrich incoming data so that it's useful to the downstream business or partner or client application. The relevance of data-driven decision is that it's best when it's close to the event's time of occurrence, which means that availability and latency are business critical to us. Those data processor apps, Kafka, and of course, Scylla can't fail. If they do, we get angry partners and clients. It looks like this. Latency and resilience are thus the pillars upon which we build our business reliable platforms. The data industry and ecosystems are always changing. Last fall, we had to adapt 3 of the most demanding data processors written in Python that we operate at Numberly. Those data processors applications were doing the job for more than 5 years, I think, and they were battle tested and trustworthy. As you know, I'm not a low-level programmer and has always felt like C or C++ cumbersome and useless for my needs. But I was following Rust maturation for a while. I was curious and I had the feeling that it could find its place between Python and C++. So when this opportunity came, I went to my colleague and told them something that looked like this. Hey, why not rewrite those 3 applications that have been running and for a while now that we know work very well into only one Rust application that we don't even know the language? Well, after the shock, they asked me for a rationale that rather than just a crazy idea. So Rust makes promises that more and more people seem to agree with. It's supposed to be secure with some nice memory and thread safety, no runtime or garbage collector. It's supposed to be easy to deploy because the compile binary are self-sufficient. It's supposed to make no compromises with strongly and being statically typed. Exhaustivity is mandatory, which is maybe a good thing. It has a very nice and neat built-in error management syntax and primitives, and it also plays well with Python. All right. But furthermore, their marketing motto speaks to the marketer inside me. A language empowering everyone to build a reliable and efficient software. Everyone? Yeah, maybe that's me. Reliable and efficient software? Oh, well, that's what my new processor app needs. Careful attendees would ask me, hey, Alexi, you did not mention speed in that list. Isn't Rust supposed to be super fast? Well, their motto mentioned efficiency, and it's not the same as speed. Efficient software does not always mean faster software. Brett Cannon, a Python core developer, argues that selecting a programming language for being faster on paper is a form of premature optimization. I agree with him in the sense that the word fast conveys different meanings depending on your objectives. In my opinion, Rust can be said to be faster as a consequence of being efficient, which does not cover all the items on the list here. Let's demonstrate that on my context. Is it fast to develop? Well, Python is way faster to develop. Plus, I've been developing in Python for more than 15 years now. Is it fast to maintain? Very few people at Numberly do know Rust, and nobody knew it in production at the time. Is it fast to prototype? Not really. The code must be complete to compile and run. Is it fast to process data? Sure, on paper, but to prove it, measure it. Is it fast to cover all failure cases? Well, in this case, definitely, because it has this couple of mandatory exhaustivity plus error handling primitives. So why would I want to lose time? The short answer is innovation. I did not choose Rust to be faster. Our Python code was fast enough to deliver their pipeline processing. So the gist of my decision was that I was sure this project was the right one at the right time to foster innovation at Numberly, because innovation cannot exist if you don't accept to lose time. I knew that by choosing Rust, I would be slower than doing it in Python. So the question is to know when and on what project you are able and you want to lose this time to foster innovation. And that's the typical case here where I found that it was worth this go to faith, let's say, leap of faith, sorry, in English. So now that I will gain, what will I gain from losing time other than the pain of using semicolons and brackets everywhere? supposedly a more reliable software thanks to Rust's unique design and paradigms. This is to say that what makes me slow is also an opportunity to make my software stronger. Low-level paradigms, ownership, borrowing, lifetimes. If it compiles, it's safe. I'm going to be stronger. Strong type safety, maybe it will give me some predictable, readable, and maintainable code base. Compilation, debug, release, etc. The compiler in the Rust compiler is very helpful compared to some random Python exceptions because you miss something in your code. Dependency management, thank you. Finally, something that is looking sane. This is a Python mess. Exhaustive pattern matching, it's very interesting because it brings confidence that you are not forgetting something or a specific case in your code. Error management primitives, it handles failure right from the language syntax. That's pretty neat as well. And explicit return values as well. It gets you a clear separation between something that has a value and something that doesn't. And it's pretty interesting, even more if you come from JavaScript, for instance, right? So I chose Rust because it provided me with the programming paradigms at the right abstraction level that I needed to finally understand and better explain the reliability and performance of my application. And I will demonstrate this to you right now. Here I come, and I went through the path of learning Rust the hard way. Why the hard way? Here is an overview of all the aspects and all the technological stacks that I had to deal with learning Rust. Getting to know the syntax, handling errors everywhere, obviously. At Memberly, we use Confluent Kafka with schema registry and the Avro serialization format. Asynchronous latency and optimized design because we are very latency sensitive in this pattern and use case. Having to deal with ScyllaDB in a multi-data center environment, dealing with MongoDB as well, Kubernetes deployment, exporting everything and metrics to Prometheus, graphing them and showing them and looking at them using Grafana, and some monitoring as well using Sentry. Since our time is limited, I will skip through this list to highlight the most insightful parts. Let's start with the first wall I hit right from the start, consuming message from Kafka. We use Confluent Kafka Community Edition with its schema registry to structurate our Avro encoded message in our Kafka topics. The bad news is that Confluent schema registry adds a magic byte to the Kafka message payloads, which breaks vanilla Apache Avro schema deserialization. Luckily for me, Hierarchy has worked on a crate to address this problem. So we work together as well on improving its performance so that it's production ready. And I'm happy to say that it's now live and available for everyone. Before we fixed this issue, I used the manual approach shown here to decode Avro messages myself with respect to their schema. So this is how you do it by yourself. Then I hit the second wall when even if my reading of the Avro payload was possible, I still couldn't deserialize them. As a total Russian newbie, I blamed myself for days before even daring to suspect Apache Avro being the culprit. I eventually read the Apache Avro source code and discovered that it was broken for complex schemas like us. Is anyone using Apache Avro in production yet? I was very, very amazed by this. So here I am contributing fixes to the Apache Avro Rust implementation, which eventually got merged 3 months later in January, thanks to its newly appointed committer, Martin. Thank you again, Martin. Anyway, another unexpected fact that Rust allowed me to prove is that deserializing Avro is actually faster than deserializing JSON in our case of rich and complex data structures. I say unexpected, but my colleague Othman was expecting it to be fair, so I was happy to finally prove him right. very interesting numbers and results. Once I was finally able to consume messages from Kafka, I started looking at the best pattern to process them. I turned to the Tokyo asynchronous runtime, which was very intuitive, coming from Python async.io. I played a lot with various code patterns to optimize and make consuming messages from Kafka latency stable and reliable. One of the interesting findings was to not defer the decoding of Avro messages to a green thread, but to do it right in the consumer loop. Indeed, since deserialization is a CPU-bound operation, it will benefit from not being cooperative with other green thread tasks. Similar, allowing and controlling your parallelism will help stabilize your IO-bound operations. Let's see that in a real example. Once deserialization is done, deferring the rest of my processing that is IO-bound to green threads helped absorb tail latencies without affecting my Kafka consuming speed. The Grafana dashboard that you see here shows that around 9 or something, something made Scylla slower than usual. Scylla select and insert P95 latency went up by 16. At the same time, you can see a bump in my parallelism load as I started having more concurrent green thread processing messages. That's the first graph over there. But it only hit my Kafka consuming latency by a factor of 2 at P95, effectively absorbing tail latencies due to this ephemeral overload in Scylla. This is the typical example of something that was harder to pinpoint and demonstrate in Python, but became very clear with Rust. Now to our dear Scylla. I found the Scylla Rust driver to be intuitive and well featured. So congratulations to the team, which is also very helpful on their dedicated channel on the ScyllaDB Slack service. Join us there. The new caching session is very handy to cache your prepare statement, so you don't have to do it yourself like I did at first. Beware that some prepared queries are not paged, so read the documentation when you want to do paging, and maybe make sure that you use the latest optimized version that is outlined here. I'm showcasing here a code example of a production connection function to Scylla using SSL, multi-data center awareness, and a caching session. All of those are to combine might be cumbersome, so here you are. Speaking of multi-data center awareness, I hit a bug in the token-aware load balancing that promptly got fixed by the team. So, and it's a version that I'm outlining here. So thanks again for this. Now, even if it's described late in this presentation, Prometheus is actually the first thing I set up on my application so that I could measure the latency and throughput impacts of all the experiments I did. I didn't get it right in the first test now, right? So for a test to be meaningful, those measurements must be made right and then graphed right. So here is an example of how I measure Scylla query insertion latency. The first and important gotcha is to set up your histogram bucket correctly with your expected graphing finesse. Here, as you can see, I expect Scylla latency to vary between 50 microseconds and 15 seconds, which is the maximal server timeout I'm allowing for writes. Sorry. Then I use it like this. I start a timer on the histogram and record its duration on success and drop it on failure so that my metrics are not polluted by possible errors. Once you measure right, you need to visualize and graph right. I created a detailed and meaningful Grafana dashboard so I could see and compare the results of my Rust application experimentations. Best time invested ever. Make sure you graph as much things as possible. Prepared statement cache size, query and throughput rates, Kafka commits occurrence, errors by type, Kubernetes pod memory in my case. There are gotchas in graphing Prometheus histograms. So I'm linking a great article that the folks at Grafana wrote on how to visualize them right in Grafana. Make sure you check it out so you can have the proper results when you do it. So, was it worth it? To be honest, the syntax was surprisingly simple and intuitive to adopt, even coming from Python. I absolutely failed to resist the temptation of testing and analyzing everything at a lower level. It was an unexpected new joy for me. So in the end, most of my time was spent on testing, graphing, analyzing, and trying to come up with a decent and insightful explanation. So this surely does not look like wasted time to me. For the number hungry of you in the audience, here are some numbers taken from the application. Kafka consumer max throughput with processing, 200K message per second on 20 partitions. Average realization, P50 latency, 75 microseconds. Scila select P50 latency on almost 2 billion rows tables, 250 microseconds, which is amazing. Scila insert P95, P50 latency on the same kind of table, 2 milliseconds. So we can fairly say that it's pretty neat as well. So it went way better than expected. The Rust Crate ecosystem is mature. To be honest, similar to the Python package index. You usually find anything you need to make your life easier. 3 Python apps totaling 54 pods on Kubernetes were replaced by 1 Rust app totaling 20 pods, so to do the same workload. We helped and worked on making the Scila Rust driver even better. So we worked on the token aware policy that can fall back for higher availability. We optimized partition key calculations. We also exposed it to create some shard aware applications, and I'll get back to it in a few. So even if it was my first Rust application, I felt really confident during the development process, which transformed into confidence in a predictable and resilient software. So now, after months of production, the new Rust pipeline processor proves to be very stable and resilient. Sentry is basically bored. So Rust promises are living up to expectations. I selected a few articles and videos of Numberly's experience if you want more material to deepen your understanding or widen your scope of knowledge around ScyllaDB database and ecosystem. And of course, make sure to check out the excellent content from ScyllaDB University. I'd like to outline, if you want to go deeper in this Rust and lower design we built on the Scila Summit 2023. I shared some very nice insight on how we modified the Rust driver to build a 100% shard aware application using Rust. So maybe we'll find this interesting as well. And I'm happy to say that we actually won a Scila award this year for this achievement. So I'm very proud of it. Numberly is hiring. If you want to join some enthusiastic teams and help us face our challenging and challenges with some community-driven mindset and innovation in mind, feel free to reach out. We are remote friendly. Wherever you are, let's have a chat. This is my email. This is a QR code that you can use and get back with. So yeah. Thank you very much for listening, and let's head down to questions maybe.
Fantastic. Thank you so much for that, Alexi. And Peter, I know there's been a couple of links shared in the chat about ScyllaDB. Sounds like there's a fantastic set of on-demand talks also available here. And then I think in the next slide, there's a look at all of the communities going on with ScyllaDB, and I know you all are very involved in all of that. So if you go to the next slide, there may be a way to see the exact links for Slack and Discord and other social media channels.
Yeah, exactly. So again, at ScyllaDB is probably going to be, you'll find us on social media, at Twitter. We have a Slack channel, which I think we put into the chat that you can take a look at. We have forums.scylladb.com. But I also wanted to let people know that there's a wonderful free online learning resource, university.scylladb.com. Probably the best place for anybody who wants to start. There will be lessons for any programming language and any level of expertise. But let's go back to that other slide, though, because again, Alexi told us about this, but he and a bunch of his peers, tons of industry luminaries, have about 30 talks on scylladb.com/summit. And so we just recently wrapped that up, and there's tons of tech talks. So anybody who really wants to get their feet wet, that is a great place to start, just to see what your industry peers are doing with something as fast as Rust and something as fast as ScyllaDB in combination.
Wonderful. We again, I think folks, if you would like to ask any questions, please do so during the console. And Alexi, while you were chatting there, a question did come in. It is, how long did it take you to rewrite these processors application in Rust? Let's start with that.
So the writing, I mean, the business logic of it maybe took something like 2 weeks total. But in the general process in learning Rust and hitting those walls, etc., if I add it to the pot, I would say it took me something like the double, four weeks total.
Mm-hmm. And then, of course, you also mentioned that you have dependencies upon these open source applications. You're committing to Avro, you're committing to the ScyllaDB Rust driver, and that was adding weeks and months to your overall time as well, right?
Sure.
Fantastic. Go ahead. If there's any questions that the audience has, please feel free to submit those. And in the meantime, Peter, I know you spent a lot of time in the community, and maybe it might be a good time to talk a little bit about kind of the learning curve with something like this, or maybe kind of the best place to get started. I think Alexi had some useful things there. There may be a couple things to talk through with the group that we could benefit from.
Yeah, I was going to say that a lot of people get kind of caught up on, like, they think NoSQL, SQL, everybody's used to that, Postgres, et cetera. The differences between, let's say, a Postgres and a CockroachDB and a MariaDB, there's a little bit of operational differences there, but for the most part, the syntax, everything's the same. And so when you get into NoSQL, it's a far more broad topic, and you have very divergent databases, from a graph database like Neo4j, a document database like MongoDB, and a wide column database like ScyllaDB. And I think, in fact, if anything, Alexis would have far more operational experience in getting your head around that. But I just want to point it out this way, that when you start with a wide column database like a ScyllaDB, you shouldn't start with like the tables and joins in mind, because you're not going to have that. Instead, you need to think about the queries. What is it? What is the data I want to get out of this? And then you should do the data model from your query thoughts first of all. And so for a lot of people, I think that's the biggest learning curve that they have to do. I call it almost like the reverse Polish notation of databases. You have to rethink how you think about a database and begin with those queries. So Alexis, would you have more to say on that?
Yeah, I agree. Query-based modeling is the first step that you need to take, even before you start trying to optimize or get too comfortable or intimate with the deep down technology behind it. It's just it's almost a state of mind, if I dare say. Just like adopting Rust new paradigms would be a new kind of state of mind compared to other programming languages.
All right, Jared, looks like we have another question from the community. You want to read that out?
Yeah, sure thing. I think it's a follow-on from the prior question. Having 3 applications in Python, doesn't it infer that a conceptual business logic was already in place? What updates were made exactly in the business logic in 2 weeks with Rust?
It's going to be hard to answer because the details are too specific to our business line. But we basically had to adapt some new IDs in the sense of identifier, not IDs, but in our data. So we had to make an evolution on the data model that we store and query and enrich because our incoming data was changing as well. So it was going to be more fine-grained data. And so we had to remodel a bit all of this. So structurally, it was spread into 3 Python applications at first because it fitted into 3 different data models that could be thought and rethought and merged into one, which doesn't mean that we only have it's the same code base, but it's adapting to the data. So we still have those 3 output and input models that we are enriching and to and from in place. But making this kind of evolution allowed us to merge the 3 of them in the same code base.
So I have a question, Alexi, because you've talked about this before, but because you use both MongoDB and you use ScyllaDB. So for a person who's approaching this for the first time, what advice would you give them as to which database you'd use for which task in an enterprise?
I think a good starter would be to actually MongoDB has their own MongoDB University as well. I would do the starter on both of them just to get a general idea of what it is that we are talking about. The querying language of Scylla is SQL. It's closer, let's say, to the standard SQL that we are used to, whereas MongoDB is absolutely and totally different. So maybe that's the first gist of building up your intuition on what you will maybe feel comfortable with, and that could be an entry point, I think. And then it's about your own feeling of projection on the scale of what you are trying to build using this NoSQL databases. Is schema and strict schema, while being elastic, but still strict schema, important to you? If so, don't choose MongoDB. I think it's too permissive, even if they have now some options to restrict this. But it was not thought like this in the first place. So they have this kind of do whatever you want legacy. But in this case, if versatility is what you are looking for and you don't really care about this, it could be an option as well. Then it's about all the features that comes with each NoSQL DB actually, because MongoDB has geo-querying built in. So if you need geodata and to be able to query geodata, maybe that's a better option. And if you only care about this, if you need very strong latency, very highly available data set, and a database that is able to scale fluently as much as your code is also and your load is scaling, I would really go to ScyllaDB. There's no point in this. The underlying architecture of MongoDB is not meant to have say, an infinite scale, whereas Scylla does from the start. So that's some important things to keep in mind. I think I think you can maybe share, and I shared the talk that I gave on this very subject. So if you're interested in learning more, check it out.
Yeah, and there was a couple of things that you just were mentioning that I would just want to expand upon. We just did some tests recently that if you want to do geospatial data with ScyllaDB, there's a package out there called GeoMesa, and we tested it. And just like Cassandra can be a backend plugin storage layer for GeoMesa, you can use ScyllaDB too. So for people who do want to do some geospatial data with ScyllaDB as a backend store, check out GeoMesa. But you're right that the native data type for geospatial data is right in MongoDB. The other thing you mentioned was the similarity of SQL versus CQL, the Cassandra query language. They are deceptively similar in many ways, at least on the input side. But one of the things you'll notice, for instance, anybody who's done Postgres will notice immediately that there's no joins, right? And of course, all the data has to be therefore denormalized. You have to have all of your data in one big table or a number of big and unjoined tables. So those are just some of the, again, it'll look a lot like SQL for SQL practitioners, but just don't try and do those joins.
And since you were mentioning graph, I would like, geo query, I would like to mention that ScyllaDB can be used to efficiently build graph databases using Janus Graph, for instance. So I know we have been playing with this quite intensively at Numberly. So that's also a nice option.
Yeah, and we have the link here for ScyllaDB Summit. There was another company called that just has recently released a new open source streaming graph database called Quine. And so ScyllaDB, again, can also be used, just like with Janus Graph, it can be used, or GeoMesa, ScyllaDB can also be an efficient storage engine for a streaming graph database. So it's very exciting what you can do with application architectures on top of the ScyllaDB as a backing store.
All right, great conversation. Well, we were chatting about that one. A bunch of new questions came in, so let's get to those. This is more on, I think, probably the framework transition. Alexei, did you find any difficulties in finding all the needed functions provided by Python libraries in Rust, or did you have to develop your own?
I didn't have to develop any of them, except all the Kafka schema registry related ones, which I had to basically use low-level functions to do it myself, to mangle within the bytecodes, the byte array, sorry. But apart from that, no. Rust is less batteries included than Python, in the sense that the standard library doesn't carry as much as the usual functions that you're used to in the first place, but they all exist in separate crates. So anytime you need something that you just had built in Python, you quickly find the right crate in your to add to your host application and just use it. So no, the ecosystem is really mature now. I think, except from some edge cases that I hit, unfortunately.
Yeah, wonderful. It's been great to see that maturation of Rust over time. That answer was not always the same, several years ago. So now there's more choice and optionality out there for folks.
Yeah.
I'll try and paraphrase this question here. How hard is it to develop a project from scratch using ScyllaDB? Since business logic may be blurred, so making the queries first, it may be a difficult approach. What's kind of the way to develop from scratch? And you talked about this a little bit with Peter earlier on, but I wonder if there's any advice about maybe getting your head around the logic or some of the guidance that we've kicked around already.
I find it pretty natural, to be honest, because when you are with business people, they ask you real questions with human syntax, right? And actually, the query-based modeling is quite intuitive in this sense that you can take a real question and model your data just based on that. You don't, not having joins and stuff like that and denormalizing, which means that you are copying the same kind of data on multiple tables, but each of those tables are specialized in answering one or multiple questions that you got asked in the first place. So there's a direct mapping between some real needs expressed in human language and some data modeling in the first place. So once you've tried it and you have achieved it once, twice, and a few times, you get the feeling that it's more intuitive than you first thought, rather than trying to think about, oh, okay, I'm gonna split all this data in all those tables, and I have to think about this primary key, this foreign key, and stuff. And this can be a nightmare, and I know that it is a nightmare because it's harder to relate to some real questions, actually. So in this sense, it feels more natural than you think. Then on the coding side, once you've done the modeling, expressing it on using the ScyllaDB driver, it's really easy enough and well documented anyway. So you won't have any trouble from there.
So I think there's two things I wanted to add to what Alexei was saying. First of all, you have in a wide column database, unlike a key value where you only have like the index and the value, here you have two elements of a key generally. You have the partitioning key, partitioning column, which then tells you how I'm going to evenly distribute the data across my database. And then within the partitions, you'll have a clustering key, or in DynamoDB's, they call that a sort key, right? So then you want to think, like, within my partitions, how do I want to rank, order, or sort data within that? So you have those two elements to play with, which you don't have in a traditional key value. So that's an advantage of a wide column database, and you really should take a look at that. And then on top of that, there are also features for maybe some irregular views of what you want to do. And so rather than redoing your entire schema, you could use what's known as a secondary index, or you can use a materialized view. And so for people who get into advanced data modeling with ScyllaDB, those are also techniques that you can use so that you don't need to totally redo your schema. You may be able to get the data, a view that you're looking for with the secondary index or a materialized view.
Yeah, very good. So I think, Alexei, if I kind of take your answer, don't necessarily be intimidated. It's probably a little bit more straightforward than you think. And certainly there's a lot of great resources that are out there for folks. All right, so we'll see if there's time for one more question, but I think this could be the last one. Before I ask the question, keep in mind that DB options here in play would be Mongo, Couch, and ScyllaDB. So keep those three in your mind. And then the question here is, leaving Rust out of it. Let's say we build a crawler using Python and the final records are stored in one of those three NoSQL databases. Which DB out of those will perform better with just Python? And if there's not much difference to be observed, that's also an option to have in play. And maybe it's something that's hard to say for sure without the exact nature of the application, but if there are variations that you've seen, maybe you can just sort of speak in generalities about when those different databases come into play.
So I think if you're talking about a large data set, terabyte plus scale, and especially if you're going to be talking about multi-data center deployment, you're probably best off with ScyllaDB. That will allow the data to be local to where your users are. so that you could have a European and a North American and an Asia data center so that the local app users will get the fastest response. As well, you can also do things like GDPR compliance by saying what data should go to which data center, right? So, but again, a lot of this depends upon scale. You can build a lot of great applications with a Couchbase or a MongoDB. I'm not going to badmouth them at all, but once you start getting past the terabyte plus to 4 terabyte to 10 terabyte scale, you'll probably find that you're scaling to multi-data centers or to keep your low latencies as you scale. You'll probably be better off with ScyllaDB. Alexei, what would you say?
MongoDB scales badly and will have a very bad impact on your TCO. If I understand it correctly, you were talking about a crawling application, which means that when I hear this, I think immediately of some write-intensive database. So that means that you will put a lot of pressure because you crawl and then you have to persist the data that you've crawled and the result in the database. So in this kind of workload, you need a database that scales very well on writes. MongoDB does not do this because you can, in a MongoDB topology, you can only have one of your machines that is the primary machine that is handling all the writes. So on this perspective, I certainly wouldn't go on MongoDB at all. And I agree with what you said, Peter. I think on the scale and then on your ability to mix this write-intensive workload and be able to get this data at scale, localized if you want. Scylla will be a great fit, I think. Yeah, and on the Python side, the shardware driver will do marvelously. So I strongly advise using the shardware driver and the shardware port on the Scylla cluster, so that you get the most out of the performance and of the data distribution of your topology. It will work very well.
Yeah, great discussion. I think in technology, the answer to every question is it depends, but that's not helpful. And you very clearly said it depends on what? Well, it depends on the scale and maybe the type of application. The write-intensive thing that you talked about, Alexei, is fantastic guidance, I think, for the audience. And there was another question that was similar. Why ScyllaDB over Dynamo or Cassandra? There may be some nuances to that, but I think the scale idea also probably comes into play there too. Anything that you would add or amend to that?
Yeah, I was just going to say that ScyllaDB was designed to really take advantage of modern CPUs. You take a look at our performance on the recent I4I, and it just blows the doors off of it. In fact, AWS used ScyllaDB as a kind of a poster child application to really get the most out of it. If you take a look at a typical load on vCPUs, and a lot of applications you see only use 30% of the vCPU, right? I mean, and in fact, you panic if the application's running 90, 95%. It's it must be thrashing, right? Typically, ScyllaDB you can be running, and you can see a vCPU utilization of 90, 95%. It looks like it's thrashing. It's not. It's actually using the whole vCPU that you're paying for. And so my question is, why are you paying for 2/3 of a box that you can't use the vCPU because the software is written so inefficiently that if it tried to go past 50%, suddenly you're panicking that the thing is about to keel over and die. So that's one of the reasons why people see these amazing cost savings of 50%, 75% or more on ScyllaDB, is that they're actually just getting the performance out of the instances that they've been paying for all along. So that's really the secret sauce behind ScyllaDB. And so when you're pairing an optimized, performance optimized language like Rust, why would you be running it with a slow boat to China application written in a piece of code that was designed for a virtual machine from the 1990s, right? You really do want to run your fast code on a fast database that's really taking advantage of 2023 generation machines and not the kind of stuff that was written before 1995.
I think that's a fantastic point. We all know that the economic situation is turbulent these days, to put it mildly. So, to your point, Alexi, about total cost of ownership and the money going towards cloud computing and IT spending, you're going to want to optimize that as much as you can. So, if you're looking for maybe a business case to do some of these things that you talked about, Alexi, maybe that's one way to go about doing it, Peter, where you can lean up your compute profile or get more efficient with what you want to do. So that's a great business case for folks out there to consider taking to their management.
And I put a link here in the chat here for the benchmarks page. There's a benchmark against DynamoDB. There's a benchmark against Apache Cassandra. And we typically play that tune with a Cassandra. If they can run a workload on 40 nodes, we show how you can run the exact same workload on 4 nodes of ScyllaDB and get the exact same performance with less than 50% of the vCPUs.
Yeah, wonderful. I think we're just about out of time, but we can maybe squeeze one more question in. Tell us about the secondary index and materialized views. There's a few pitfalls folks have noticed with Cassandra. What has been the experience like with ScyllaDB?
So in Cassandra, you have local secondary indexes only. That's all you can do. So they're not they're fast, but they don't scale across the entire data set. With ScyllaDB, you have the option of using either global secondary indexes, if you truly want to do a secondary index against the entire data set, or you can use a local secondary index, which those will be faster, but again, not the whole data set. So it really depends. We give users the choice as to which kind of secondary index they want to use for their data. As well, if you've ever listened to people running with Cassandra, they do not claim that they're materialized views are production ready, where ScyllaDBs have been in production for years now.
See some head nodding from Alexi there. Wonderful. That's all the time we have for today. We're at the bottom of the hour here. Thank you, Peter, for helping put the presentation together, and thank you, Alexi, for talking about your story here. Sounds like you have had a fantastic journey with ScyllaDB and all things distributed systems. So there's lots of great links in the presentation that'll be shared out to everybody so people can follow along. Peter shared the ScyllaDB Summit link. Thank you both for your time, and thank you, audience, for your time and attention and really thoughtful questions. This recording will be available to folks on demand, so stay tuned for that. On behalf of Peter and Alexi, I'm Jared from InfoQ. We'll see you all next time.